Good morning and good afternoon. This is Monica Paolini from Senza Fili. This is a conversation on the new role of voice in LTE networks, where we have VoLTE and Wi-Fi calling, providing a new type of voice services. Today, I'm talking with Michael Campbell, Director of Service Assurance at EXFO. Michael, thanks for being with us today.
Good afternoon, Monica.
So I would like to start asking you, what is your role at EXFO, and what is EXFO doing in terms of voice and trying to capture voice quality in the new networks?
Okay, my role is, as you said, Director of Service Assurance. Myself and my team have product management responsibility for all of EXFO's active and passive probing line, the EXFO Works troubleshooting and analytics system, and of course our mobile agent, which is both an active and a passive agent that can live in the background on mobile phones and report as part of the overall infrastructure. So you can probably guess from what I've just said that our role in the area of voice actually is end-to-end service assurance for voice calls that are traversing both fixed VoIP, mobile to mobile, and particularly, of course, today we're talking about VoLTE. So the entire infrastructure that EXFO makes available to measure service assurance in VoLTE and VoIP calls largely falls under the remit of myself and my team.
Yeah, that's very exciting. And you've been working on voice for quite some time at EXFO. So can you tell us how is the voice changing in terms of the requirements, in terms of how you measure quality? Because it's the same, from a subscriber point of view, it's the very same thing. You talk to people over the phone. But from a network point of view, it's fundamentally different.
Well, in the old days, if I could start there, in the old days, voice was certainly not a simple matter, but it was all very tightly controlled by carriers who had very well-groomed circuits and owned all the endpoints, and everything could be tuned very tightly. In today's world, what we find, particularly in the area of VoLTE, is that we are actually crossing large numbers of organizational silos as a call, for example, progresses from a VoLTE handset, say, to my office phone here, for example. Perhaps the biggest challenge from an organizational perspective, there's both technical challenges and organizational challenges. The biggest challenge from an organizational perspective is just that you cross so many silos. You cross the wireless silo, you cross the fixed line backhaul transport silo, you cross the IMS silo. You may actually end up in the worst case back in an old PSTN device that you're calling, and there's another silo again. All of that has to work end to end with perfect quality for a user to have a good experience of voice, particularly in the VoLTE environment. So that's an organizational issue. From a technical issue, VoLTE is really extremely complex relative to many earlier calling mechanisms that you could use. For example, the issue of latency, signaling latency in particular, is extremely critical, and it's a lot tighter and a lot more demanding than a lot of previous technologies have been. So there's a whole raft of technology challenges, there's a whole raft of organizational internal challenges, and all of those things make voice more difficult to deliver today than it has been in years past.
Yeah, I'm glad you raised the issue of organizational challenges, because this is something that we often focus on the technology and we leave the organizational issues aside, but they're quite important, and oftentimes to slow down the adoption of new technologies. So how can you help operators deal with that, and what is it they're doing, and how is that you help them in dealing with this need to break down the silos and get the different units work together?
Well, again, if I can hark back to the old days, there was a whole set of technology that assured the radio link, another whole set that assured backhaul links, and every one of the silos had their own set of tools, and they did not really work very well or correlate their results together to understand the actual user experience. Instead, it was how well did the technology for each one of those silos work. What we're doing is end-to-end service assurance. So in the end, we're providing a single pane of glass view of the entire call, irrespective of the technology silos that it crosses. So we're allowing operators to see the user experience. We're redefining this from a user experience perspective as opposed to a technology perspective. You can then, of course, drill down into the technology when you find an area that is causing user problems. But I think fundamentally, what are we doing to make this easier? We're bringing it all together, we're correlating it all together, and we're providing meaningful intelligence on the overall service experience.
Yeah, and so it is important for an operator to get the end-to-end view, but how does it work? Because you need to have end-to-end, a sense of how it's working end-to-end, but then if there is a problem, you need to be able to drill it down and understand where is the problem coming from. So how do you work with that?
Well, we have a system that actually covers all of those silos and is able to report up into a common infrastructure. So, for example, we have a mobile agent that can tell you about the mobile and the AirLink side of the call. We have backhaul assurance, which can tell you about that. We have IMS assurance that can tell you what's happening there. And think of every piece of that set of silos we spoke about. We have parts of our system which can instrument that. We then are able to bring all of that data together into a single system that we call EXFO Works, which then feeds a whole series of analytics from a higher level visualization and KPI layer we call extract. So how we do this is we bring it all together. We can instrument all parts of the call path, and then we can bring it all together. And I think part of our secret sauce is that we are correlating the information coming from all parts of that in the context of the user call in real time. So when you see something on a KPI dashboard, for example, that says you've got a problem with voice moss or something like that, you can drill immediately into that, and you can actually see, for example, a call ladder diagram that will show you all the pieces of the call, clearly highlight those areas that may be having issues, and literally you can click on that and you can dive down into that piece of it.
Yeah, and so now we're shifting to the technical part of it, challenges, and it's interesting to see how the two work together. So, and you mentioned real time. So before we get any further down, can we define what is real time? What kind of real time? What kind of granularity of real time do operators need?
Well, that's a large and complicated topic. I think everybody says they're real time. So the question is, how real is real time? Let's see. The quickest example I can think of is the topic of microbursting, which can occur in as you're nearing congestion. These kind of things can become quite important. These are transient events that really disrupt a call experience. And how long are they? They're measured in milliseconds. So that's the kind of real time that you need. You need the sort of granularity where you can capture that kind of event and you can view it on that kind of a time scale. So typically we're talking, for an ordinary calling environment, second level granularity, but we can go right down to sub-second granularity and allow you to capture really transient issues that are really bedeviling your user experience in the end. So how real is real time? It's really real.
And what do you do with real-time information? Because, so historical information, you take it, you think about it, and then you move on. But with real-time, you have the opportunity to also act in real time. It's not just to know real-time, to have real-time information, but to act on it. How do you help operator to act on it?
Well, I think probably the easiest answer there is our extract system, which allows you to present real-time dashboards to operators. There is, of course, a whole series of alarming and other capabilities which can trigger in real time as things happen. So we can certainly alert NOC personnel as stuff like this occurs. But a very straightforward way of looking at this is just you will see indicators, for example, turn red on a dashboard, and you can click into those areas and drill through.
Yeah, right. And so this is a way for the operators to have access, and then they can decide depending on whatever their network is and their strategy. There is also the component of, before you get there is all the analysis that you're doing as well, right? So because it's not just getting the data, but to make it visible. So you need the dashboard, but you also need to do a lot of work before you get there. Can you tell us how you got to that data, to combine all these different sources? It's a very complex issue.
Well, it really is, and we're aware, for example, that a lot of our competitors do what I like to call just-in-time correlation. So when an operator realizes there's an issue and they start to dig, then the system goes and polls all of the various data sources and probing elements and starts to stitch that all together as the operator asks. This is just in time okay, but it also takes a lot of time. A lot of our competitors, we're quite aware, have systems where they may not be able to stitch the call together for multiple minutes of going out there and probing various elements of their system and understanding all this. By contrast, our system takes all this information up in real time, as we just discussed, and it's being correlated in real time as it comes up. So everything is being stitched together in real time and is available in that format the instant you want it. So this means that when an operator decides to dig into something, the information is almost instantaneously available. Now, that sounds like a great little technical point, but it actually turns into a really meat and potatoes sort of financial issue when you think about it, because that means that operator is going to get to resolution of the problem in a much shorter period of time than they would have if they had to wait while the system crunched around and decided what were all the parts of the call. So in the end, what we do is you could look at this as reducing MTTR, and that directly translates into reduced OpEx for the operator.
Yeah, so there is clearly a benefit, but there is also a cost to pay in the sense that it's more complex for an operator to manage their network at that, this way in real time. And there is a huge amount of information out there. And when I talk to operators, sometimes they feel like they're overwhelmed by the amount of data that is there. How can you help them to make use of the data but not be overwhelmed by it?
Well, I think if I mention secret sauce, that's probably part of our secret sauce again. So the classic example is you have this fire hose or gusher of data coming up from the system and almost no intelligence. It's all just data. And I talked to one operator who said what they have to do is what they called neuro-optical correlation, which is to say they had to eyeball all this stuff and figure out what was going on. We've automated that process, and we do that kind of not just correlation, but analysis and provision of analyzed results, or what we like to call actionable intelligence, as opposed to just here's 83 KPIs, and you can drill into any one of them and get gigabits of data. It's not like that. Instead, we can actually tell you directly what's wrong and where.
Yeah, and can you tell them also what's going to be wrong soon? So predict problems as well. Because that's another, you want to prevent a problem, not just correct it, if you can.
So predictive analytics is an area that is really hot in today's market. And the simplest form of this, of course, is just trending KPIs and looking at them and being able to observe where issues are likely to happen. And we support that kind of trending and alarming on that sort of thing. So you can define service models in our system, and you can define alarm points based on those, and actually achieve that kind of result.
Right. So we talked about the different parts of the network where you might want to be testing, but there is also a sort of another dimension, and it's how you test it. So there is some tests that it's more device-driven, passive testing, active testing, and then you need to pull it all together. How do you deal with the different parts? Are you working on all of them?
So that's a great question, Monica, and that's something that kind of highlights the one of the real value propositions with EXFO. There's a number of ways to think about any given service that's being delivered to a subscriber. There's and we're all familiar with the 7-layer protocol model. There is a physical infrastructure network which is transporting these calls and doing all the signaling and all the rest of that. There's the media traversing it. There's the call setups and takedowns over the air and so on. All of these things are unique pieces that are ultimately transported by a physical network. They also use a whole series of common elements like diameter routing agents and CSCFs and all sorts of other pieces like that. There are really two things you want to assure when you look at assuring a network like this and the services you're delivering over it. One is the actual infrastructure itself, and the other is the services that you are delivering over that infrastructure. And what's really unique about EXFO is that we have both an active portfolio of products, which is largely targeted at assuring that infrastructure, and then there's the passive portfolio of products, which is targeted at being able to look at the customer service experience. So we really get to both pieces of that. And then, of course, we have the mobile agent, which actually does both of those things from the other side of the air link, which is a really difficult place to be, and probably the weakest link in the whole service chain. So, and then of course, you take all that stuff, and if you hark back to what we've just talked about earlier, all of that information is being correlated in real time and presented up together in a meaningful fashion. So we are looking at both the infrastructure and the services over the infrastructure and are able to do meaningful correlation between both of those pieces. which is really quite a unique capability.
Yeah, and it's also a complex type of task, because we know what it is to, you have a call, you say, is it good or bad, but how does that relate to the network infrastructure, which is eventually what you need to do in order to improve it. You need to do it. There's a lot of learning there to do. Can you explain a little bit about the active versus passive approach to testing? Because you need both, but you need it for different reasons. Can you explain that?
Sure, yeah. So active assurance has a number of really very valuable use cases for an operator. I think one of the things we like to talk about is just the life cycle of a service. So if you think about something that you're offering to the customer, you're probably turning up network elements, installing them, turning them up, making sure they're working, and then you bring them together and start to offer a service over them. Active assurance allows you to actually test each of those elements in isolation and then start testing them together. You can build this outwards into the overall service and test it all without actually having to subject users to the experience until you know it's good. So instead of using end users as your probing devices, you can use active assurance to do this, and you can validate that the network infrastructure, the service infrastructure you built, is actually going to work well before you put real live traffic through it. So that is the, that's I think a huge value of active assurance. Passive assurance, of course, at that point then allows you to actually measure how it really performs when direct end user traffic is going through it.
Yeah, and I guess that the active performance it's very useful also in predicting problems or potential performance issues, because you can see ahead of time before you get into real deployments, like for upgrades and things like that, correct?
Absolutely. So you touch really on the topic of change management, and that's another major thing that you can really do incredibly well with active testing. When this is something I think every operator probably spends an awful lot of time doing, usually at night. But when you upgrade a card, put in a new ROM load, upgrade some firmware, whatever it may be, you're changing some element of your network, and the ability to actually pre-test that before you unleash subscribers on it is incredibly valuable, and that's a major use case for our active assurance. We've seen so many cases where operators don't do this. They make a big change in the network, and about, 7 o'clock in the morning, when subscribers start to pile onto the network in volume, all of a sudden all hell breaks loose. Well, if you used active assurance, you know ahead of time that that's not going to happen, and you've saved your subscribers from a lot of problems.
Yeah, absolutely. Now, with virtualization, with the move to virtualization, a lot of this approach that relies on physical probes doesn't work that well anymore. So we need to move on. What is it you're doing in that area?
We're actually really excited about virtualization. This is a really dynamic new area. It's our opinion, actually, that this is a significant inflection point in the entire telecom business, and that includes assurance. So quickly, to answer your question, what are we doing? Well, we do active, we do passive, and we're doing all of that in a virtual way as well. So we have virtual active verifiers, we have virtual passive verifiers. We have all of those systems that I just talked about, EXFO Works, Extract, and so on. These are all just software working on servers. So they are all virtualizable, orchestratable, and all of the great NFV kind of things that you can do. Virtualization also gives you a whole bunch of really interesting new use cases, which will allow operators to potentially save a fair amount of money. My favorite example of this is making use of the idea of infrastructure assurance. So as you build out a service in real time, which is really what NFV will allow you to do, you can spin up a small number of active assurance elements and check the service path and make sure that it's absolutely correct. The moment you notice anything wrong, you can then spin up a passive element or one or more passive elements and monitor customer traffic only where you think there really are going to be problems. So you can minimize to some extent the passive footprint by using active in a virtual environment, because now everything can be turned on, turned off, redeployed. It's a wonderful new paradigm which should let operators not only deliver services with higher velocity, but also deliver the assurance of those services in an equally facile and very fast way. We're right at the forefront of this and are working very carefully with a number of partners to allow all of this to be orchestrated and run in an NFV fashion.
Well, now also you can start virtualizing your service assurance, testing, monitoring ahead of having a fully virtualized network, right? Because there is a lot of it that there is a value, so all the cost savings can come in before you have the full network virtualized.
Well, one of the things that's really exciting about this, and so absolutely yes, and the first step of this, I guess, is what I call Whitebox virtualization, which is really, here's my functionality and I'll run it on your servers. That really doesn't sound very exciting. You haven't really done any of that clever orchestration and just-in-time service stuff. But that enables a whole bunch of interesting new use cases now, because what that's done is allowed you to scale the size of each one of those elements to fit the point in the network where you want to deploy it. So I could put out a minuscule verifier basically anywhere I'm delivering a service, and it's a significantly more cost-effective sort of proposition for a carrier than it might have been otherwise.
Yeah, yeah.
That's just one of this is an exciting new frontier. There's just so much stuff we can do with this, and we are leading the charge in this area.
Sounds like you're having a lot of fun in that. Now, let's look at the future. What's up there in terms of what you guys are doing, what you're seeing in the market in terms of requirements?
You know, I think we've kind of talked about the biggest inflection point that's happening right now, and that's the whole migration towards NFV SDN. You know, I'm fond of saying, for those of us who are in this business, if we haven't made that migration completely in about 5 years, we're not going to be here to talk about it. Think about what happened when we migrated from TDM to VoIP. It's kind of what you said at the beginning, you know. It's the same service. I pick up a phone and I talk to you, and it feels and smells the same to me, but everything associated with delivering that has changed. And if you didn't change with it, you're not part of the service path anymore. So this is the biggest, it's not only short-term, it's long-term future, because we go from simple white box virtualization to sort of infrastructure testing to the full NFV orchestrated network environment. That is huge. So that's one of the really big things that's happening. The whole Internet of Things, IoT explosion, I think, is another really big thing that we're digging into in a serious way. That's another major inflection point that we're going to be dealing with. And there are more prosaic things like the whole move towards OTT video. This is changing how people consume video entirely. And although we haven't really talked about it today, EXFO has a full line of video assurance capabilities as well, and a very strong OTT ABR offering in that space. All of that, of course, can be virtualized as well. So all these pieces kind of tie together into a wonderful technology brew.
Yeah, and I guess, you know, increasingly voice cannot be looked at in isolation. It's just part of the whole set. So you need to, you know, as you're doing, to look at voice, data, video all together. Well, Michael, thank you so much for talking with us today and sharing your insights.
Thank you so much, Monica.
So, well, thank you so much for watching our conversation. I had Michael Campbell with me today from EXFO, and this conversation was part of a report by Senza Fili in collaboration with RCR Wireless News. And you can download the full report online as well. Thank you so much, and have a good day.